All right, welcome back to our next video in our series on programming in Snap. This is covering a lab that I call Jump Mario Jump. This is undoubtedly one of the tougher labs we'll see the whole term. Be patient with it, give yourself time. There's a lot of moving parts, and if you start early, don't try and do it all at once. Take breaks, you should be just fine. All right, so the idea is we are building on top of a previous project we did called Run Mario Run. In Run Mario Run, we were able to use left and right arrows to move Mario back and forth. He was able to interact with Bowser. That all worked pretty well. The shtick here is that we are going to put Mario in a basic world. You know, there's those green sewer pipes that he goes in and out of. So we're going to put the ground. We're going to put in a left sewer pipe and a right sewer pipe. And Mario. And that's all we need for this one. We can take Bowser out. We can take the Fireball out if you still have those in. The objective is we want Mario to be able to move left and right, but if he tries to move into one of the sewer pipes, he's stopped. He should be able to jump. When he jumps up, he should be able to land on the ground, or he should be able to land on top of the pipes. And if you're looking for an extra credit opportunity, you can add enemies that Mario can interact with, which is pretty cool. All right, so let's take a look at what this thing looks like. I've got Mario, and I've got my sewer pipes, and as you can see, Mario moves back and forth. He's got those costume changes, so it looks like he's running. I can have Mario jump. Notice the fluid jumping motion. He doesn't teleport up, teleport down. He isn't moving up a fixed linear rate up and down. And when he's in the air, I can move him left or right as I desire. So I have made sure that my code can respond to that. Furthermore, if I put him up on a sewer pipe, he stops on the sewer pipe. He can jump up here. If I want, he can jump off of here. And the one that's going to be tricky to figure out, well, I'll give you some hints for this. If he walks, boop, he just falls right off the edge. So the question is, how do we create nice falling movement, right? When we look at real physics, we see that when Mario starts jumping, he moves quickly, but as he reaches the top of his jump, he's moving slowly, and then as he moves back down to the ground, he accelerates toward the ground. So he's moving up, he decelerates, which causes him to come to that brief pause right at the very top, then he accelerates back down to the ground and stops. How do we achieve that? I have a recommendation, but I'm going to back up. Before I show my code, I'm just going to let you know, students tackle this a lot of different ways. If you have an idea for how you want to approach it, try that first. This next little bit of code that I'm going to show you, one, anybody is allowed to use this code for their project or can be inspired by this code. And two, it's just one way to tackle it. What I think is useful is if we have a variable called velocity. The idea is velocity tells me how fast I should be moving. And I'm going to direct you to two things to start with. I have a variable called velocity which starts at 0, and when I go to move upward in the air, I'm going to change y by velocity. And then whenever I change my velocity, or whenever I move up by that amount y, I will decrease velocity by 1. And what that means is my little arrow here, which I'm going to go ahead and demonstrate, should be able to jump. There he goes. There he goes. What makes it look so it's got nice fluid physics is, you know, if my velocity was 5, well, it moves up by 5, then 4, then 3, then 2, then 1, then 0. I guess it wouldn't move for 0. And then velocity becomes negative. It goes down -1, -2, -3, -4, -5, until it reaches this ground point again. I don't know how well this will show up in the video, and I know it's kind of, the numbers are jittering a bit. We can address that a little bit later. But when I go up, watch how the number, right, it has a period where it's positive, a period where it's negative, until it returns to a neutral value. So what am I doing in my code here? Well, for starters, I'd like to direct you to the new way I'd like to handle user inputs. Up until this point, we were using these when blocks, when left arrow key is pressed, when right arrow key is pressed. That's fine for our earlier labs, but the problem is the rate of detection for these when blocks is pretty slow. What that means is your keyboard will be short on responding if you use a when block. What I prefer instead of the when is what I call forever if. And the way it works is you can put as many if statements as you want in here, forever if, whoops, not there. You chain them together just like this. And what that does is it allows you to check for any given input that you want, right? So it could be if up arrow key is pressed, if left arrow key is pressed, if right arrow key is pressed. And then we also don't end up with these timing issues. You can have multiple when blocks and you're trying to press left arrow key and up arrow key, and we're just not sure what's being processed when. Whereas if we put it in this forever if chain, we know it looks for up, it finishes whatever responsibilities it has for an input of up, then it looks for maybe left, and it deals with left. It looks for right, it deals with right. It allows for multiple inputs in a way that's clean, number one. And number two, forever if can just process more commands per second, or at least that's been my experience. So I recommend when you're setting up your inputs, right, Mario is supposed to be able to go up, he should be able to go left, he should be able to go right, and I should be able to handle multiple of those inputs at once. So using forever if is going to be a good way to do that. I think this might also be our first instance of these. Oh yeah, because what we really used was when space key is pressed, or when left arrow key is pressed. So this is a new block for us, and it begins our adventure into sprite collision. So in this sensing category, there are a bunch of things we're going to use, but the one we're talking about right now is for a particular arrow key. If key up arrow is pressed, that allows me to set up this forever if chain for inputs. The other one you're going to want to think about is from the perspective of, say this is Mario, I want to ask the question, is Mario touching, if I made another sprite, if this other sprite was called sewer pipe, and this first sprite, we'll name it Mario. Always a good idea to name your sprites because it helps you tell them apart. So I'll put the sewer pipe over here and Mario's over here. I can say, Mario can ask, hey, if I'm touching the sewer pipe, have a particular behavior. And what's useful about that is you can say, all right, as I'm moving, if I find myself, oh, it crashed, no way. Oh, I can't believe it just did that. Well, thanks, Snap. I'm going to show this video anyways. What the touching block does is it says, hey, look, if I end up touching the other sprite, then what I want you to do is maybe stop moving or back up. So if you look at this right here, I'll tell you, I'm not going to show you the code, but what prevents Mario from moving through these pipes is I have a block that says something to the effect of, if you try to move left and you find yourself touching the sewer pipe, back up. And that allows Mario to make sure that he's never touching one of the pipes. The other thing I would say is, as I'm falling, I can pick Mario up and put him anywhere I want, and he tries to fall. As I'm falling, you may notice I actually have two different sprites for each sewer pipe. There's the base right here that I'm not allowed to move through, whether it's left or right. Let's see if I can figure this out. Yeah, see, he's stuck on this side. He can't move through on that side. But I'm able to fall on the top, but that's because these dark green rectangles are actually different sprites. So I'm going to recommend when you build this, make a sprite that you can't move through left or right, make a sprite that you can't fall through, as in when you're falling, continue falling until you touch this dark green sprite. That'll make your life a little bit easier. Okay, anything else we wanted to point out about this? You will notice, oh, I guess that code got killed, but you will notice that it can be a little bit hard to get Mario to stay in one spot. I would say that the best grade for this project will be the students that are able to figure out how to make the movement as fluid as possible. So less jittering around and kind of teleporting back and forth. As clean and smooth as you can make this interaction will help your grade be as best as possible. Okay, thanks for watching.